Hey guys, so it was brought to my attention that it might be a little bit easier if I made a video going over the PowerPoints. So I figured I'd give that a go this week, and you guys let me know if it helps you guys out a little bit more. Um, um, you guys might notice I might skip some stuff, so that's just me trying to not really skip over information you don't need to know. Just the less I'm going to try to keep this more to the information that I feel you guys absolutely got to know. Because there's 55 slides, so I'm not trying to make this a hour long. If I spend a minute on a slide, so I might skip over some. You guys all have access to this PowerPoint, so just keep that in mind. If you see me skip over stuff, all right. So chapter 7. Gas metal arc welding and flux cord arc welding equipment and supplies. I'll probably call the GMAW MIG welding and the FCAW flux cord. FCAW and GMAW just, I don't know, it takes too long to say, I guess, or it's just habit. All right. Okay, another thing. It's brought to my attention that there's learning objectives for each chapter that we cover. So I'm going to try to stick to those. I'm going to try to stick more to those. And I'm pretty sure I grabbed just quiz questions and stuff like that covers this. So if you pay attention to the learning objectives in the PowerPoints and in the book, that's really what I'm trying to push from here on out. I was kind of scattered last semester, so I'm trying to fix that. So we're going to describe the function of MIG and flux cord station components, identify the various types of shielding gases used with MIG and flux cord, and describe their characteristics and evaluate their effectiveness. That's probably a pretty big one. Different welding situations call for different gases, and you kind of need to know why. And so if you're working on something and you're switching around, you need to know if you need to switch gases or not for better penetration, better coverage, hotter welds. If you're going from short circuit to spray, you need to know what kind of gas you need to use. Identify and specify the various electrode wires used for MIG and flux cord using the tables provided in the book. It's a lot similar to stick welding, so it follows the same kind of 4-digit dash digit charts. Not really the charts, but the same tables. Yeah, I don't know why they have a flow meter over there on that page. Okay, so arc welding. Gas metal arc welding, or metal or inert gas MIG, is a process in which an arc is struck between a consumable metal electrode and the metal workpiece. Flux cord is the same, except instead of a solid wire, the flux cord wire is hollow. It's like a tube with flux in the middle of it, so it's basically like the reverse of a stick electrode. So stick electrodes on the inside, covered with the flux. Flux cord arc welding is the electrode with a flux on the inside. I personally really like to flux core weld. That's just me. It's easy. MIG welding and flux cord both use continuously fed wires. So as soon as you strike an arc, you hold down that trigger, it starts welding. The wire is the electrode. That should be pretty obvious. Give me just 1 second. I don't know if I get rid of this camera. Oh, I can kind of drag that up there. Okay, that's out of the way. Alt-T. Cool. Okay, sorry, I had a bunch of pop-ups and blocking my way. So the wire is the electrode. Flux core arc process is used to weld only ferrous metals and nickel-based alloys, so you can't do stainless steel or aluminum with flux core. And and it is generally performed semi-automatically, and can also be. Come on, go away, slide. Go away. What does this do? Okay. So I can go back. Okay. Usually it's just handheld, but it can also be used with machine. It's a little bit more. You got to read the PUD a little bit more on FluxCore, so it's possible, but it's harder to set it up on a robot to do it. Here you can kind of see like a diagram of the FluxCore wire. So like you'll have the wire on the outside and the like powder flux on the inside. Granted, it's like real packed in there, so it's not really a powder. But this is for self-shielded, so that means if it's FCAW-S, that means that it's self-shielded. It doesn't need like a gas for it. So they're a little bit nastier, a lot thicker smoke, stuff like that. FCAW-G is for gas shielded. It's a little bit different, but it's still FluxCore. The advantages for self-shielded, are you can use it more outside. You don't have to carry around a bottle. It does pretty well in out of position welding. There's a higher weld spatter and higher levels of smoke. Slag is much harder to remove, and the lower deposition rate, so you don't get as much weld in the same amount of weld area as you would with gas covered. For the gas covered, it's used more often indoors, where you can lug around a gas ball a little bit easier. The shielding gas keeps oxygen and nitrogen away from the weld, so you have a lot fewer weld defects like porosity or wormholes or worm tracks. Produces a weld with good mechanical properties, so it's a little bit stronger. It's more. I would think it'd be more for like structural welding. Produces far less spatter, and you have a higher deposition rate, so you can put a lot more weld down a lot faster. A gas metal arc welding station uses constant voltage for the power source. You'll have an electrode wire feed mechanism, so it's usually a spool of wire that's fed through. I'm having a brain fart. Wire rollers. I couldn't think of the rollers. You can kind of see that on the video I posted earlier on the machine. There's 4 of them on the Miller machines we have here. Shielded gas cylinders and flow meter. There's a gas regulator. You have your welding gun or torch. Workpiece lead, also known as a ground clamp. I call it the ground clamp. It's just a habit of mine. It's the same thing, basically. Electrode wire, and most of them will have a coolant system, and so most do have a coolant system. It gets pretty hot, so you have to keep the torches cool. Remote controls, booth, table, ventilation, those are optional. We have all of those except for remote controls. Don't really know what that's talking about. Here's a common outfit. So you'll have a wire reel that's fed through some wire feeders, some rollers. It goes through your lead to your gun, to the tip of your nozzle, and come out, strike an arc on the workpiece. You have your shielding gas. And you'll have like a regulator and a flow meter. So a regulator just sets the pressure that the gas is going in there, and then the flow meter controls the volume of gas pushed through your gun. That's really important right there. It's the volume of gas flow, not like the pressure that's fed out. Okay, you feed it when you're setting a flow meter. It's always like cubic. I think it's like cubic feet per hour, or minute, or I'm pretty sure it's hour. So it's always the volume is what the flow meter controls volume. regulator controls pressure. Okay. MIG and flux core stations pretty much use the exact same equipment, and self-shielded arc uses a different welding gun, and it doesn't have a gas bottle, obviously. Power sources, MIG and flux core use a constant voltage power source. Power sources can include transformer, rectifier, inverter, and engine-driven generator types. I'm fairly positive that all of the MIG machines out there are transformer rectifiers. That's more into like the electrical side of things, which I'm not gonna lie, I don't know a whole lot about the science behind the machines. I just know how to use the machines. That's something I'm working with Bob, the Ivy Tech guy, to help learn more about. Usually, most places, if your machine has an issue, they bring in a maintenance guy, or they have a maintenance guy that fixes it. So, I don't know. I don't really know a whole lot about those machines out there when it comes to like the electrical side of them. Direct current electrode positive (DCEP) is used for MIG welding. Like I said in my MIG welding video, the MIG welding machine video, 90 to 99% of MIG welding and flux core is going to use direct current electrode positive. The only things that I know that use something else are self-shielded flux core that uses negative, and aluminum MIG welding, which uses AC. Off the top of my head, that's the only things I know that is different. So spray, globular transfer, short circuit transfer, those all use positive. So the constant voltage power source maintains a constant arc length. So that's just how, when you're welding, it keeps the same arc length all the way across. Arc welding machine amperage is changed proportionately when the wire feed speed is changed. So I actually don't know a whole lot about the amperage. I know for 045 wire, when you're using MIG welding, short circuit, 045 is a 1-to-1. So if you have your wire speed set at 275, your amperage is 275. And I think 035 wire is like 2/3 of that. Well, I'll cover that more when we get into actual welding. I gotta look into that a little bit more. If there's like a diagram or a chart or something to use on how to find your amperage. For MIG welding and flux core, you'll set the volts and the wire speed, and that sets your amperage. So, I don't know anything about that. So the wire feeders, wire electrode used in MIG welding comes in large coils or drums that contain hundreds or thousands of feet of wire. Here we'll use 44-pound spools. It takes a whole lot of welding to go through one of those spools of wire. If you're running a machine, you can get like 55-gallon drums of coiled wire. So there'll be miles of wire in that drum. Wire feeders may be contained inside the gas metal arc welding machine or separate from the machine. Some will have a panel that you'll lift up from the side, put the wire on, close the panel, continue going. I like those a little bit better because it keeps your wire cleaner. All the machines we have here, it's located on the top, on the outside, so they do get a little bit dusty. They do make these like red Scotch-Brite things that you pop on your wire when it's going into your wire feeding machine that will scrub it clean. I'm trying to get some of those. I'm sure it would help with the welding a little bit better. Wire feeds consist of the coil mounting device, a set of drive wheels for the wire, and an adjustable constant speed motor. You can kind of see on the video again. So we had the mounting device where the spool was actually mounted, the drive rollers or wheels, and I called it a tension. It's a tension setter, but that's the adjustable constant motor, speed motor. So that's just how like fast it's running or how much tension those rollers put on that wire. Drive rollers have one of 3 groove designs. So they have a V groove, which, the groove will look like a V. so that it can fit a bunch of different types of wire in there. A knurl groove and a U groove. I personally like the knurl grooves a little bit better. It seems that to me that I've had more luck with those not bird nesting. Um, drive rolls are designed to work with a specific electrode diameter. So like here you can see it says 045. So those would be where for an 045. You can see an 045 there too. So you just have to pay attention to your wire size and your roller speeds. If you put 035 wire in here, it wouldn't move it at all. It'd be too small. The wire would be. So here you can see the typical roller setup. So you have your electro spool hub. That's where you put the wire. And then you feed it through here, through your drive rollers, through here, into your gun. Here you have tension adjusting knobs, inch switch and purge switch. The inch switch or jog switch, I'm going to call it jog switch because Miller just has jog. On the wire, drive control panels is used to rotate the drive motor slowly. When you hold down the jog button, and you can set your wire speed to whatever you want. So if you need it to go a little bit slower, you can do that. Or if you're trying to add new wire to the system, you can crank it up and it'll shoot out of there really quick. Purge switch on the wire feeder or power supply may be provided to clear the hose and gun of air. You can also use that to like flush out like a previous gas that you were using. So if you are using 100% CO2 on one job and then you just switch to a 75-25 argon CO2 mix, then you can purge the 100% CO2 out. Or most commonly, it's going to be used to just set your flow meter, so that you don't have to hold down your trigger on your MIG gun. Shielding gases used with MIG can be inert, reactive, or mixtures of both types. Inert gases don't react with other chemicals or elements. Argon and helium are both inert gases. Oh, that kind of sucks. It cut one off. Reactive gases react with other chemicals. That's going to be like your CO2. I don't know what else it says down there. Gas mixtures or 100% carbon dioxide are used to weld steels. CO2 is carbon dioxide. Pure argon is used to weld most non-ferrous metals, so like your aluminum, Hastelloy X, Inconel. Hydrogen and nitrogen are used in specialized applications. I've never once used any of those. The gas or gas mixture selected is determined by the metal and the arc transfer method desired. So you couldn't use pure argon on spray transfer. It just wouldn't work. And you couldn't use CO2 on aluminum. The arc would just be too unstable. Cylinders are available in a bunch of different sizes, and they are manufactured to Interstate Commerce Commission specifications. Some gases are stored as liquids. The quantity of gas in a cylinder is determined by the high pressure gauge or volume scale if stored as a gas, and the weight if stored as a liquid. Safety tip: thread the cap securely over the cylinder whenever cylinders are moved or in storage. So if a cylinder doesn't have a cap on, it has to have a regulator on, and if it doesn't have a regulator on it, it has to have a cylinder, okay, or a cap. A cylinder truck is recommended for moving cylinders, a little dolly or cart. Fasten cylinders to wall or stable objects when in use. That is super important. Never ever leave just a cylinder sitting in an aisleway or out in the shop or anywhere unsecured. Always store and use gas cylinders in the upright position. You can't lay it on its side. It messes with the pressure. Use in-store cylinders according to local building and fire codes. So you don't want to, leave your oxygen and your acetylene together, making a big bomb. Regulators control the rate at which gas is expelled from the cylinder. So here you have a regulator. This is going to be done with pressure, and this is going to be done with, this is your flow meter. This is going to be cubic feet per hour or something like that. CF, yeah, CFHM or some CFH. Yeah. Uh, this is by volume. This is by pressure. Flow meter scales are accurately only if gas entering them is about 50 psi. So once a bottle gets down to less than 50, it's kind of hard to tell. The flow meters aren't really worth much. Flow meters measure the rate of gas flow. The volume of the gas coming out of the nozzle is measured, and different flow meters or different scales must be used for each gas. So here you can see uh, this is for carbon dioxide. Most of them will have like an argon CO2 side, and then some will have like a argon helium side. You just have to pay attention to that and use the right scale. Carbon dioxide is only used on carbon steels and low alloy steels, and carbon dioxide reacts with and oxidizes the base material metal. Moisture-free carbon dioxide must be used. Maintaining the proper arc length is critical. Carbon dioxide is the least expensive shielding gas. Carbon dioxide, 100% CO2 is what we use. It makes the arc just a little bit more harsh, and you'll get a little bit better penetration, but it's cheap. So I'd probably say most places use a 75-25 mix, so 75% argon, 25% CO2. Gas mixtures for MIG welding to overcome the tendency for filler metal not to flow to the edges of the weld. A gas mixture is used. For steels, oxygen or carbon dioxide is added to argon. If you add oxygen, it makes it a little bit hotter. It's going to help you get into the spray transfers. And CO2 is just to help. And I think it cools it down just a little bit. Adding oxygen or carbon dioxide to argon or helium causes the shielding gas to become slightly oxidizing. This can cause porosity in some ferrous metals. Argon and helium are generally used with non-ferrous metals. Helium is used when high heat input is required in a welding application. Argon is heavier than helium and provides a better shield. Argon is often used for out-of-position welding because of its lower heat conductivity, and argon costs less than helium. Helium is super expensive. The weld bead, contour, and penetration are affected by the gas used. So here you can see argon, you're getting a little bit of penetration with a little bit of undercut. Here you can see the undercut. Argon and oxygen, or argon and CO2, you get better penetration and no undercut. With helium, you have a fatter, flatter bead. Argon and helium, so it's still a little bit flatter, and you get a lot of penetration. And then with carbon dioxide, you get a whole bunch of penetration, but it causes the weld to spatter a lot more. Shielding gases for flux core. The self-shielded does not use an externally supplied shielding gas. That's what the flux is for. Most common shielding gas for gas shielded flux core is carbon dioxide, and gas mixtures are also used. The proper combination of shielding gas and electrode is required. So when we get into the wire classifications, that'll tell you a lot on the gas that's needed. So a MIG gun, here you have a typical MIG gun. The welding gun directs the welding electrode into the weld. The gas hose, electrode lead, and liner are built into one large cable. And some air-cooled guns have a power pin connection. So here you have this is what plugs into your wire feeding system, and that those O-rings are what prevent your gas from leaving the gun and going into the gun and around your cable and out your nozzle. MIG guns are usually air-cooled. Water-cooled guns are required for continuous welding or welding at amperatures above 300 amps with argon shielding gas. Spool guns have self-contained wire drive units. Pull-type gun has a motor and drive rolls in it, which pull the electrode wire. in the MIG machine video, I briefly showed you a push pull gun on the aluminum welder we have out there. In push pull systems, the welding gun pulls the wire while the wire drive at the power source pushes the wire, so it just helps it move at the same rate. Aluminum wire is really easy to kink, and it'll kink inside your lead, so it's easier just to have it pushed and pulled. Welding guns for automatic gas metal arc welding: straight neck and nozzle, no handle or trigger attached to a carriage or other mechanism for welding. Welding guns for robotic MIG welding, bent neck attached to a robot. Yeah. The electrode selected determines the type of welding gun required. Gas-covered flux cord requires a different welding gun than self-shielded, and guns can be water-cooled or air-cooled. So it's pretty much the same. Contact tips. So this is a contact tip. This is a nozzle. This is an adapter. I also call this the gas diffuser. In most of them, this is what's going to, so those little holes is where your gas comes out of. A contact tip transfers electrical current from the welding gun to the electrode wire. So you have to make sure that you have the right tip for the right wire that you have. So like if this is an 045 tip and you try to run 035 wire through it, it's not going to work very well because it's not making the contact that it needs to. So your amperage and your voltage is going to be off. A contact tube threads into a contact tube adapter or diffuser. The adapter threads into the welding gun. Most of them have an insulator just to make sure you don't shock yourself if you're touching it. Nozzle fits on the end of a gun and directs the shielding gas into the weld area. You'll see some MIG guns have a real tight nozzle, and then some have a big nozzle. That just depends on the gas and the type of welding that you're doing. Nozzle designs vary, and exit diameters are measured in 1/16 of an inch increments. Liners. So a liner it's going to look like a giant, like tightly wound spring that goes all the way through your gun. It's what keeps your wire from kinking. The liner is installed in the cable that carries the electrode from the wire feeder to the welding gun. For most applications, a coiled steel wire liner is used. A nylon liner is used with aluminum electrode wire. That just helps keep your wire from getting contaminated by the coiled steel wire. A lot of talking. Oh, look, I'm on 37 and 55, so we're almost done. Some accessories, welding pliers, whelpers. I'm going to call them whelpers as a brand. Are useful tools. Function as wire cutter, hand nozzle, nose pliers. You'll see, well, you can't really see on this side. On this other side, this other side will be kind of like a file. It helps clean debris and spatter out of your nozzle. Many arc welding machines have a remote control circuit switch and external plug. Don't know what that is. Remote adjusters are used to adjust wire feed speed or voltage. Okay, electrode wire selection is based on base metal composition, base metal properties, cleanliness of base metal, shielding gas, and welding position. MIG electrode wire is usually continuously solid. Electrode wire, metal cord wire is a second type. Metal cord is pretty new. I've never used it. I don't quite understand what it is. And the AWS has an identification system for MIG electrode wires. So here you can see aluminum is going to be ER 4043 or ER 5356. Low carbon carbon steels ER 70S-2 or -6. I think we use the -2 here. Stainless steels, you got your ER 308s, 308Ls, 316, 347s. The rest of that is like super specific, or like, what you'll need it as. I pay close attention to this slide too. So electrode rod, the 70 is the minimum tensile strength, just like in stick welding. The S is going to tell you if it's solid or cord. And the 6 is going to be the chemical composition of it. So letter number, low alloy steels. So that's going to show you if you're using it on low alloy steel, what to use it on. Don't need to know that. We're not going to cover that yet. So the functions of flux, it's add deoxidizers and denitrifiers. Don't know what that is. It adds alloying elements, forms gas to shield the weld area, create a slag covering over the weld bead, stabilizes the arc, and it traps impurities in the molten weld metal and float them to the top of the metal of the weld to form slag. So the classification is pretty much the same as MIG wire. So you have E electrode, 70,000 pounds minimum tensile strength. T for tubular, and -1. The -1 is going to tell you like what kind of wire it is, or the chemical composition of the flux. I know -11 is for self-shielded. I think we use E70T-1 for gas shielded and E71-11 for self-shielded. Yeah. So here we have the 70, the same thing for the electrode designations. Electrode, minimum tensile strength, position, electrode construction, so tubular, and then all of that information is kind of, you don't hardly ever see that actually on any wire. That's like getting like really specific. Dash numbers indicate the following: electrode polarity, if shielding gas is required, and the number of weld passes recommended. The shielding gas to be used can be indicated by the letter in the final position. We're going to talk about stainless steel. I'm not going to talk about smoke extracting systems, because we did that already. Filter lenses for gas shielded arc welding. Because of the clearer atmosphere of the arc, the operator must use arc welding lenses with a darker shade. This will reduce eye fatigue and prevent possible eye damage. Most helmets for gas arc welding use a clear cover lens and a filter plate. Keep lenses clean. If I'm flux coring, I usually use a 12 or a 13 lens, shade on my welding hood. It's a lot brighter. Your eyes get tired a lot faster. Protective clothing, it's going to be the same as stick welding. Leather clothing provides the best protection. Heavy wool or cotton can also be worn. Dark clothing reduces the reflection of light behind the helmet. So if you're wearing a black t-shirt, the light's not going to hit your chest and bounce up into your hood and blind you. Leather gloves should also have to be worn, especially with flux core. Flux core is hot. It is hot, hot, hot. They actually make a thing to put over your glove called the hot hand. It's a reflective thing that helps reduce the heat on the back of your hand just because it's so hot. Safety review. Make sure electrical connection leads are in good condition. Use adequate ventilation and filters to protect against fumes. Wear proper clothing. Do not carry flammable materials. Close pockets and don't have cuffs. Wear a welding helmet with proper lenses. And I can't read that last one. Oh, and that's it. So that's the PowerPoint. Let me know if this helps you out more. It's kind of a long video, so if it doesn't help, I'm not going to do it. But if it does help, I'll continue to go through the PowerPoints. Yeah, just let me know if you guys want me to do this for the next one. Next week I should be having a lot more exciting videos because I'll actually start MIG welding. We might spend 2 weeks on that just because there's a lot that I want to cover. Hopefully you guys come back soon and can actually start MIG welding. But yeah, I'll see you guys later.